Hello students, this is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad. In this video, I'll take you through the solutions of NTA's test paper number 7, the mathematics part. Let us begin. First one, if log of x plus y is equal to 2xy, then y dash of 0 is equal to. Very straightforward problem. You have log of x plus y is equal to 2 times xy. And the question is dy by dx at x is equal to 0. So go ahead and differentiate this straight away. What will this give us? Differentiating the left hand side is 1 by x plus y times, differentiate this term, that would give us 1 plus dy by dx. This would be 2x into dy by dx, plus if you keep 2y constant, you will get dx by dx is 1. Now here, instead of solving for dy by dx, rearranging and all that, the simpler thing is to substitute the values x is equal to 0 and the corresponding value for y. Now when x is equal to 0, y you can find from this equation, right? So substitute there, log of x 0 plus y is equal to 2 into 0 into y, or log y is 0, y should be 1. Therefore when x is 0, y is 1. So using these two values in this equation, you get dy by dx at x is equal to 0. That is, let me write it fresh, 1 by x is 0, y is 1, 1 plus dy by dx is equal to 2x dy by dx, and x is 0, so 2 into 0 into dy by dx plus 2y, right, 2y, and we found y is 1, so 2y is 2 into 1. Therefore this whole thing is 1. So I have 1 plus dy by dx is equal to 2, this is 0. So dy by dx is equal to 1 at x is equal to 0. Okay. So the answer is 1, option A. Remember, don't waste your time trying to solve this for dy by dx and then substituting x and y. You can do that already here. Okay. Question number 2. The value of the parameter a such that the area bounded by a squared x squared plus ax plus 1, the coordinate axis and the line x is equal to 1 attains its least value is equal to. Now these are maximum minima problems. The minimum is the question here. Basically, the given curve y is equal to ax squared plus ax plus 1 is going to be a parabola, and since it is positive here, it is an open upward parabola and could roughly be something like this. Now they are speaking about the area bounded by this curve y, the coordinate axis, so this area, and x is equal to 1. So this area is how much? Basically it is integral, the area is integral y dx from 0 to 1. The question is, for what value of a will this area be minimum? Okay, so let us find the area first. What will be the area? The area is integral 0 to 1, y is given as a squared x squared plus ax plus 1 dx. Now this becomes a squared, remember you are integrating with respect to x, x cubed by 3 plus a x squared by 2 plus x. Now this would give us a squared by 3 after substituting the limits plus a by 2 plus 1. So this is our area. Now we have to find where it will attain its minimum value, right? So how do you do maximum or minimum problems? Differentiate this and equate it to equal to 0. That is, for a to be minimum, dA by d small a should be equal to 0. And what is dA by d small a? A squared by 3 plus a by 2, right? So a squared by 3 becomes 2a by 3, and then a by 2 becomes 1 by 2 is equal to 0. Now this would give me, this is dA by d small a. This would give me a is equal to minus 1 by 2 by 3, a is minus 1 by 2, a is equal to minus 3 upon 4. And d square a by d a squared is going to be, differentiate this again just to check if it is minimum or maximum, I get 2 by 3. This is always greater than 0. Therefore, this is a minimum. Therefore, A is equal to minus 3 by 4 is the value for which this curve will enclose a minimum area. Okay, very simple problem. The answer is A is minus 3 by 4, option C. Question number 3. If integral square root of tan x plus cot x dx is equal to I, then I equals what? An indefinite integral problem. See, now this is a bit tricky, but not very difficult. Convert tan x and cot x to sines and cosines. So this can become square root of sin x by cos x and summation cos x upon sin x. Now, if you take the LCM, this integral becomes square root of sin x, not sin squared, sin x cos x, and here while cross multiplying, the square root of sin x and square root of sin x becomes sin x, square root of cos x and square root of cos x become cos x. Okay, now you have to remember here a certain substitution. You take t as sin x minus cos x. Okay, you'll see the advantage of this. The dt part at least is very clear. Dt will be cos x plus sin x dx, which gives us the numerator completely. How to get the denominator? Find t squared. T squared is sin squared x plus cos squared x minus 2 sin x cos x. Sin x cos x. Now from this is 1. So t squared minus 1 is minus 2 sin x cos x, or sin x cos x can be written as t squared minus 1 by minus 2, or 1 minus t squared by 2 basically. Okay, so you got the numerator as dt and the denominator as 1 minus t squared by 2, this part, right? So the integral becomes dt upon square root of 1 minus t square by 2. So take the root 2 outside and I have integral dt by square root of 1 minus t squared. This is nothing but sin inverse of t, standard formula. And we know that t again is sin x minus cos x. So square root of 2 sin inverse of sin x minus cos x, which is option sin inverse of sin x minus cos x, option C. Okay, very simple. The substitution is t is sin x minus cos x, and get the sin x cos x also in terms of t. Question number 4. Now this is an interesting problem. The digit at the units place of the sum of 1 factorial square plus 2 factorial square plus 3 factorial square plus 4 factorial square plus 5 factorial square up to 2008 factorial square, or that number can even be large. Now how to calculate this? It was factorial and square, and obviously there is no way we are going to add up and check and all. So the answer lies in this trick. You know 5 factorial is how much? 120, right? So 5 factorial squared, big number, is 14,400. Now 6 factorial, for example, 6 factorial will also be 720. So its factorial also, its 6 factorial squared will also be a big number with 2 zeros. Now 7 factorial also will have 2 zeros, 8 factorial also 2 zeros, 9 factorial 2 zeros, 10 factorial will have 4 zeros at least, because 10 brings another 2 zeros. So that way what I am trying to say is that all these numbers end with at least 2 zeros in the end. That is, from 5 factorial square onwards to the end will have at least 2 zeros in the end. So only the first 4 numbers will decide the units place and the tenths place. So only find the first 4 and you are done. That is, 1 factorial square is 1, 2 factorial square is 4, 3 factorial square is 6 square 36. 4 factorial square is 24 square 576. So this becomes 7 and 627. So the digits in the units place is 7. Answer is option B. Units in the tens place is 2. You can check that. You can tell that also, because the tens place unit is going to be 2. Now the hundreds place unit and all, you can still find, but you'll have to go till that, let us say at least 9 factorial, which is going to be big numbers already. Okay, so the units place is 7. So the key was to recognize that 5 factorial onwards you will have 2 zeros at least in the trailing end. In the end you will have at least 2 zeros. Question number 5. A, B, C be any real numbers. Suppose that there are real numbers x, y, z, not all 0, such that x is cy plus bz, y is az plus cx, and z is bx plus ay. Then a square plus b square plus c square plus 2abc is equal to. Now what they have given us here can be written as some linear equations. This is a problem based on the consistency of linear equations. If I write it in the standard form, I can write it like this. First equation. Second equation, minus cx plus y minus az is 0. And the third one, minus bx minus ay plus z is equal to 0. Now this is what we call a homogeneous system, right? Because a homogeneous set of equations has all zeros on the right hand side. Now for this, x is equal to y is equal to z is equal to 0 is a solution, and this solution is called the trivial solution, right? Now what they have mentioned is x, y, z are not all 0. That is, there is a non-trivial solution. If there is to be a non-trivial solution for such a system, we know the condition is that the determinant of the coefficients should be 0, right? For this to be non-trivial solution to exist for this system, I need the determinant of the coefficients plus 1 minus a minus b minus a plus 1 to be equal to 0. Let us evaluate this determinant quickly. 1 into 1 minus a square plus c into ac plus b, ac, c into c, excuse me, maybe mistake, c times c minus c minus ab. Minus c minus ab, then minus b times ac plus b should be 0. Now this is 1 minus a squared minus c squared minus abc minus abc minus b squared is 0, or a squared plus b squared plus c squared plus 2abc. You take all this to the other side is equal to 1. Very simple problem. Just guess that this is based on the condition for non-trivial solutions of homogeneous system of equations. Moving on to question number 6. Now this is an interesting question. If f of x is sine of limit t tends to 0, 2x by pi cot inverse of x by t squared, then integral minus pi by 2 to pi by 2 f of x dx is equal to. Now the first thing would be to check what happens when t tends to 0. When t tends to 0, this becomes 0, so this becomes infinite, where x is not equal to 0. But if this is infinite, cot inverse of infinity is what? 0. Tan inverse of 0 is infinity, cot inverse of infinity is 0. But at the same time, this would obviously mean that the whole function is 0, sine 0, and therefore the integral should be 0. But there is a little bit of a trick here, because x can take negative as well as positive values, right? And they have given specifically a t squared here to make sure that this part is always going to be positive. Because what I mean is, if I have cot inverse, when x is greater than 0, cot inverse of x by t squared is going to tend towards infinity, right? As t tends to 0, this is going to tend towards infinity. Therefore, you can say x is equal to 0. But when x is, the limit, the cot inverse, the whole thing, let me say, in other words, to make it a little more clear, let us say something like this. Limit x upon t squared as t tends to 0 is going to become infinity, plus infinity. Therefore, cot inverse of infinity will be 0. That is, this number is going to be 0. So 2x into 0 will be 0. So sine, the whole thing is 0. So f of x can be told to be 0 if x is greater than 0. If x is less than 0, what happens? Limit t tends to 0, x by t squared will tend to minus infinity. And cot inverse of minus infinity is not 0 but pi. Because you know the domain of cot inverse is 0 to pi. Right? So the negative values will be on the other side, in the second quadrant. So this is pi. Now what does this mean? This means f of x, when x is negative, this whole term is pi. So it becomes sine of 2x by pi into pi, or sine 2x when x is less than 0. So you see, you got the definition of sine x, of the function f of x. F of x is 0 when x is greater than 0, and sine 2x when x is less than 0. Now you can do the integral. So the integral minus pi by 2 to pi by 2 of f of x dx can be written as minus pi by 2 to 0. In the negative region it is sine 2x, we know. And from 0 to pi by 2 we know the integral is 0 dx because the function is 0. These are positive values of x, these are negative x. Okay. So therefore, integrate sine 2x is minus cos 2x by 2 from minus pi by 2 to 0. Therefore, this is going to be minus cos pi minus of minus cos 0 upon 2. This is going to become minus of plus 1 basically, and another plus 1 upon 2. Right? So answer is 1. So the answer to this problem is 1. Excuse me, I think I made a mistake in the sign. Major mistake. Here the upper limit minus lower limit, I have inverted the order. One quick correction, excuse me. So when I put 0 first, it is minus cos 0 minus of minus cos pi by 2. So this will be actually minus 1 minus 1. Minus 1 minus of 1. This is going to be plus 1. So the answer is minus 1, option B. Okay. Very simple. Identify that when x is positive, this is going to plus infinity, and therefore cot inverse is 0. When it is negative, this is going to minus infinity, and cot inverse is pi. Okay. Mathematical reasoning. If P implies not P or Q is false, then the truth values of P and Q are respectively. Okay. Now first we have to come to this place, and then we'll see what is the truth values of P and Q. Let us take P and Q. P is, let's say, true, Q true, true, false, false, true, false, false. Now we need not P, and then we'll do not P or Q. Now not P is false, false, true, true. Now not P or Q, true or false is true, false or false is false, true or true is true, false or true is also true. So not P or Q is done, and then now we have to do P implies not P or Q. You know about the implication, right? When it is true and true, it is true. When it is true and this is false, then it is false. When this is false and this is true, it can be true. When this is false and this is true, okay, it's obviously true. The same condition here. So they have given that P implies not P or Q is false, which is this condition. Then the truth values of P and Q are T, comma F, which is option D, T, comma F. Okay, very simple. Just follow the rules. We written PQ, not P or Q, and then P implies not P or Q. Question number 8. The foot of the normal from the point 4, 3 to a circle is 2, 1. That is, there is a circle. Okay, something like a circle. The foot of the normal from the point 4, 3 to the circle. So from here I am drawing a normal to this circle, perpendicular to the tangent at this point basically. And this point is 2, 1. Okay. And then a diameter of the circle has equation 2x minus y minus 2 is 0. There is a certain diameter, which means it passes through the center C. This diameter has the equation 2x minus y minus 2 is 0. Now the question is, the equation of the circle is what? Okay, how to find? Now you see that this normal to the circle is nothing but the radius, right? Radius is always normal to the circle. Therefore, this straight line is another diameter actually. It will be the equation of another diameter of the circle. So if you find this equation, this line, and then you have another diameter, you can solve and get the center. Once you get the center, you find the radius and then you solve the circle. Alright? So this is what we are going to do now. The first thing is to find the other diameter. The other diameter is the line joining 4, 3 and 2, 1. So line joining 4, 3, 2, 1 is x minus x1, x minus 4 by x2 minus x1, 2 minus 4 is y minus y1, y minus 3 by y2 minus y1, 1 minus 3. So minus 2 can be cancelled, x minus 4 is y minus 3 or x minus y is equal to 1. This is one equation. Okay. The other equation is this 2x minus y is equal to 2. Alright. Now solve for these two equations. Subtract them both. This is 1, let us say this is 2. Now 2 minus 1, if I do, I get x is equal to 1. Right. And substitute it back here and y is equal to 0. So x is 1, y is 0. So I got the center now. Okay. Now we have a circle whose center is known 1, 0 and there is a point on the circle 2, 1. How to find the equation? First find the radius. The radius is going to be the distance between these 2 points. So square root of 2 minus 1 square plus 1 minus 0 square, basically root 2. Okay. So the equation of the circle with center h, k, let's say radius r. If center is h, k and radius is r, x minus h the whole square plus y minus k the whole square is r square is the equation of the circle. So in our case it is x minus 1 the whole square plus y minus 0 the whole square is r square, which is root 2 squared. Or this becomes x squared minus 2x plus 1 plus y squared is 2. Or x squared plus y squared minus 2x minus 1 is 0. Alright. Very simple problem. X squared plus y squared minus 2x minus 1 is 0. Option C. See, all the idea that we are using is the normal to the circle is going to be a diameter. It's a radius and the radius diameter, the equations are going to be the same. So find that line and the point of intersection gives you the center. Question number 9. If x is rational, that is it is not irrational or a complex number, it's a real rational number, and 4 times x squared plus 1 by x squared plus 16 x plus 1 by x minus 57 is equal to 0, then the product of all possible values of x is what? Now of course, instead of forming a power 4 equation by taking an LCM of the whole thing, what we can do is, if you think of this identity, x squared plus 1 by x squared is nothing but x plus 1 by x the whole square minus 2. Substitute that there. So that becomes 4 into x plus 1 by x the whole squared minus 2 plus 16 into x plus 1 by x minus 57 is 0. Correct? So this means if I take x plus 1 by x as some t, okay, for the sake of simplification, this is 4t squared minus 8 plus 16t minus 57 is 0, or 4t squared plus 16t minus 65 is 0. Okay, so how to get the factors of this? Now the factors of this are only 13 and 5, apart from 65 and 1, 13 and 5 are the only factors. Now this can be written as 4 and all that. But how to get 13, 5 and then to get 16? Basically what we are talking about is the product of these two is 260. Now we have to split this into two pieces, which on subtraction would give you 16. So obviously it is plus 26 and minus 10, right? And then divide both by 4, you get 13 by 2 and minus 5 by 2. I hope you know all these techniques. So it is nothing but 13t plus 2, okay, and 2t minus 5, right? So this way I would get sorry, I messed up the last step. This should be 2t plus 13, that is, it should be 2t plus 13 times 2t minus 5 is 0. Now let us use, this would mean 2t plus 13 is 0 or 2t plus 5 is 0. So let's go to the equation, which is this for t, and then see which of these will give us rational solutions. 2t plus 13 is 2 times 0 implies 2 times x plus 1 by x plus 13 is 0. Or taking the LCM and all, it becomes 2x square plus 13x plus 2 is 0. Now the roots of this would be minus 13 plus or minus square root of 13 square, 169, minus 4ac is 4 into 2 into 2 by 4. So minus 13 plus or minus square root of 153 by 4. This is not rational. Not rational. So let us go to the next one, that is 2t minus 5 is 0. This would give me 2 times x plus 1 by x minus 5 is 0. So 2x squared minus 5x plus 2 is 0, or 2x minus 1 and x minus 2 is 0, and I get x is either 2 or 1 by 2. These are rational, right? Therefore, the question is product of all possible values of x. Of course, there are 4 values of x. So there are 4 different roots, but 2 are irrational, 2 are rational. So the possible values of x are 2 and 1 by 2, product, which is 1. So the answer is option D, 1. Moving on to question 10. The mean and variance of 20 observations are found to be 10 and 4 respectively. So the mean is 10, variance is 4. On rechecking, it was found that an observation 9 was incorrect, 9 incorrect, 11 is correct. So then the correct variance is how much? Okay, they have given n is 20. So the same idea, if x bar is 10 and n is 20, sigma x is going to be x bar into n, 200. Now from this 200, the new x bar is going to be, you remove the incorrect one and add the correct one. That is going to be 202. Therefore, the new mean x new is going to be 202 by 20, which is 10.1. So the new mean is 10.1. This is needed to find the new variance. Because what is the expression for variance? See, variance can be written as summation of x the whole square by n, xi square, okay, minus summation of xi by n the whole square, or x bar squared, right? This is the formula for standard deviation. Summation of xi by n the whole square minus x bar the whole square. Okay. Now we know the new value. We have to find the new value of summation of xi squared. How to find the new value of summation of xi squared? Quite simple. Now the same thing. We'll use the same logic. From this equation, since sigma is given, we'll find what is the incorrect value using all the incorrect values. Okay. So this is going to be 4. So 4 is equal to summation of x whole, let us say, the whole square by n is 20 minus, and I have here x bar the whole square. X bar the whole square is nothing but 10 squared. Okay, sigma x by n the whole square is here, so 10 squared. So in the old case, this is how they would have calculated the variance. So from this, what do I get? 104 is equal to summation of x whole squared by 20, summation of x whole square inside. So summation of the x squared whole is going to be 104 into 20, or 2080. Now from this, the new summation would be, you have to remove the incorrect, add the correct. So remove the 9 square and add the 11 squared. So this would become 2080 minus 81 plus 11 squared, 121. This becomes 1999 plus 121, or the sigma x squared new is going to be, what do I get here? 2120. So the new variance, sigma square new, can be written as the new x bar, new summation of x the whole square by n is still 20 minus the new mean square. And what is the new mean? 10.1. So this is going to be 106 minus 10.1 square. 10.1 squared is 102.01. Okay, and this on subtraction is 3.99. So the answer is 3.99, option A. A very simple problem, nothing much to worry. Just correct the new summation of x and correct the new summation of x squared. Okay. Okay, question number 11. The sum 3 by 1 squared plus 5 by 1 squared plus 2 squared, so on up to 20 terms is equal to. What is the nth term in this? The nth term, or let us say the rth term, the numerator is 2r plus 1 basically, right? Because 2 2s are 4 plus 1, 2 3s are 6 plus 1 7. And the denominator is summation of r squared from 1, or let us say summation of k square from 1 to r. 1 square plus 2 squares, 1 square plus 3 square. Numerator is 2r plus 1, and the denominator, we know the expression summation of k squared from 1 to r is r into r plus 1 into 2r plus 1 by 6. So the TR can be simplified as 6 by r into r plus 1 or using partial fractions. Imagine you can split the whole thing if you think like this otherwise. Add and subtract r to the numerator. This r plus 1 by the whole term and r by the whole term can be split as two things. So 6 into 1 by r minus 1 by r plus 1 is tr. So they are asking us summation of tr from r is 1 to 20. So if I keep that 6 common, the first term is going to be 1 by 1 minus 1 by 2. Second term is 1 by 2 minus 1 by 3. Third term is 1 by 3 minus 1 by 4. Up to the 20th term is going to be 1 by 20 minus 1 by 21. And as you can see, all the inner terms are going to be cancelled, right, till 1 by 20. So all I will get is 6 into 1 minus 1 by 21, or 6 into 20 upon 21, or 120 upon 21. Now what is the question they are asking? They say that the answer is equal to k by 21, then k is equal to. So if this is equal to k by 21, k is equal to 120. Right? So the answer k is 120 is option B, 120. Moving on to question number 12. If tan k plus 1 theta is equal to tan theta, then the set of all the values of theta is. Very simple problem. Let us just go straight forward expanding this. This can be, the term can be written as tan k theta plus theta, right? And tan k theta plus theta is nothing but tan k theta plus tan theta by 1 minus tan k theta tan theta, right? So simplifying the terms, tan k theta plus tan theta is equal to tan theta minus tan k theta into tan squared theta. Tan theta and tan theta are gone. So if I bring it to this side, I get tan k theta into 1 plus tan squared theta is 0. Okay, tan k theta, and here plus tan k theta tan squared theta. So I take the tan k theta common. Now 1 plus tan square theta cannot be 0 because it is sum of two squares, right? So this has to be 0. So if tan k theta is 0, we know this general solution is k theta is n pi. N can be any integer. So theta has to be n pi by k, where k can be any integer. So n pi by k is option C. Very simple question. Use this trigonometric identity and get the general solution. Okay, another complex number problem. If z plus 1 by z plus 1 is 0, then z power 2003 plus 1 by z power 2003 is equal to. Now you see this whole thing, if I write it as a quadratic equation, taking the LCM, this implies that z square plus z plus 1 is 0. Now the roots of this are the omega and omega square, the cube roots of unity. So the key to this problem is to recognize that z is a cube root of unity. Okay. Once you find z is omega, substitute that here. So omega raised to 2003 plus 1 by omega raised to 2003. Now this can be written as omega raised to 2001 into omega squared, and the same way omega raised to 2001 into omega squared. 2001 is a multiple of 3, so this becomes 1. So the answer is omega squared by plus 1 by omega squared, which is omega squared plus omega. And we know 1 plus omega square is 0. Therefore, omega square plus omega is minus 1. So the answer is option B, minus 1. Very simple problem. Recognize that it is omega. Okay. 14. When the elevation of the sun changes from 45 to 30, the shadow of a tower increases by 60 units. Then the height of the tower is. So when there is a tower, and when the elevation of the sun is 45 degrees, let us say this was sun, and when its elevation was 45, so more or less like this. The sun was at 45 degrees, shadow was so much. Okay, let us say the tower's height is h. When the elevation changes from 45 to 30, so that is, it will become a smaller angle. The sun moved here. They've said that the shadow now, earlier the shadow was this much, right? If the building was here, this was the shadow. Now the shadow is so much, and this extra length is 60 units. Then the height of the tower is how much? Very simple heights and distances problem. Take the first, let us name the triangle ABCD. In triangle ABC, tan 45 is, let us call this x, is h by x, or tan 45 is 1, so 1 is h by x, which implies h is equal to x. Okay, so this is also equal to h. Now in the bigger triangle ABD, in triangle ABD we have 30 degrees here. This is h plus 60 and this is h. Therefore tan 30 is h upon h plus 60. Tan 30 is 1 by root 3 is h upon h plus 60. H plus 60 is equal to root 3 h, or 60 is root 3 minus 1 h, and this has to be rationalized. H is 60 by root 3 plus minus 1, so this can be rationalized as root 3 plus 1 and root 3 plus 1. A squared minus b squared gives this 2. This is 60 into root 3 plus 1. 2 and 60 on cancellation can be written as 30 into root 3 plus 1 units. So the option is 30 into root 3 plus 1 units, option C. Very simple heights and distances problem. Let us go to question number 15. The value of limit x tends to infinity 3x minus 4 by 3x plus 2 the whole raised to x plus 1 by 3 is. Now you see, this is how the form limit x tends to infinity f of x par g of x. But f of x, if you see, is 3x minus 4 by 3x plus 4, and as x tends to infinity, this tends to 1, and g of x is x plus 1 by 3. As x tends to infinity, this function tends to infinity. So this is how the form 1 to the power infinity. Now there are several ways to do here. You do the L'Hospital's rule. You first change the question to x tends to 0, bring it into an L'Hospital's rule form, and then using that solve the problem. Or there's also the other technique. Such limits of 1 to infinity are equal to e to the power f of x minus 1 times g of x limit x tends to infinity. Okay, so here let us do what is the value here? Limit x tends to infinity, f of x minus 1 is 3x minus 4 by 3x plus 2 minus 1 times g of x is x plus 1 upon 3. So now this becomes limit x tends to infinity 3x plus 3x minus 4 minus 3x minus 2 upon 3x plus 2 into x plus 1 by 3. So this becomes minus 6, right? So this limit can be written as limit x tends to infinity minus 6 into x plus 1 by 3 into 3x plus 2. Now this is fairly simple to evaluate, right? What we usually do, the technique for infinity, is to take the maximum out. If I pull x out, I get x plus 1 by x, and if I pull 3x out from the denominator, I get 1 plus 2 by 3x. So this can be cancelled, and x tends to infinity, this becomes 0 and this also becomes 0. So the limit is minus 6 by 9, which is minus 2 by 3. Therefore, the final answer is e raised to minus 2 by 3. If you see, we said limit e raised to, limit x tends to infinity, f of x minus 1 into g of x. Okay, so e raised to minus 2 by 3, option B. So far so good. Quite simple problems in this test. Let us see this. If f of x is sin x plus cos x and g of x is x squared minus 1, then g of f of x is invertible in the domain. G of f of x, what is g of f of x? G of f of x becomes sin x plus cos x the whole square minus 1. That is, you substitute f of x in g of x. This is sin squared x plus cos squared x plus 2 sin x cos x minus 1. So this is 2 sin x cos x, or simply sin 2x. So g of f of x is sin 2x. Now the function sin 2x is invertible if this 2x is between minus pi by 2 and pi by 2, and pi by 2, right? Then it will be a unique function, unique value function. Therefore, x should be in the limit minus pi by 4 to pi by 4. This is invertible if. So for 2x, this is a condition. For x, it will be in this region. Of course, you can have the inclusive limits also. That's how we get the closed interval minus pi by 4 to pi by 4. Because outside this limit, then x is the sine of 2x is a multiple valued function. So from it will be one to many kind of inverse which doesn't exist. Question number 17. Another question based on functions. For x is a real number, f of x is mod of log 2 minus sin x. F of x is mod of log 2 minus sin x. Okay. And g of x is f of x. G of x basically is f of x. Then what can we say about g dash of x? How will this function be? First of all, log 2, how much is the value of log 2? Log 2, I guess something around 0.69 or so. 0.693, etc. So log 2 is a number less than 1, and sin x can be between 1 and minus 1. Therefore, there is a chance, there is a region in which when sin x is greater than this 0.69, it is going to be negative. This thing will be negative. And so using those ideas, those kind of ideas, let us try to find whether that function will be here or positive or negative and all that. Okay. So what have they asked us? G dash of 0. We need G dash of 0. How to find the G dash of 0? Basically, if you see this question here, this looks like G of x is f of x. So G dash of x is nothing but you differentiate this f dash of f of x, and then you differentiate this, the chain rule, right? F dash of x. Now G dash of 0 is going to be f dash of f of 0 and f dash of 0. Now we need these two things, f of 0 and f dash of 0. And then if you substitute them here, then you can see what will be the value of all these things. So first thing, let us see what is f of 0. Let's go to the next page. Here what we have so far is G dash of 0 is f dash of f of 0 and multiplied by f dash of 0, and we have f of x is mod log 2 minus sin x. Now if you see in the neighborhood of 0, when x is very close to 0, let us say like this, in that region very close to 0, sin x is close to 0, so it will be less than log 2, correct? Log 2 is 0.693 I said. So therefore you can say that f of x, since the whole thing is positive, the log can be removed. So f of 0 is easy, is just log 2, and f dash of x also is easy to calculate from here. F dash of x is minus cos x. So f dash of 0 would be minus cos 0, which is minus 1. Alright, so far we've just done f of 0, f dash of 0. Now we need another term here, f dash of f of 0, right? So if I put f dash of f of 0, that is f dash of f of 0 was log 2. Okay, so now that's substituted here. F dash of log 2 in this expression will be minus cos log 2. Okay, therefore g dash of 0 is this multiplied by f dash of 0, which is minus 1. So it is cos of log 2. So remember, the idea is that close to 0 the function is differentiable, it is continuous and everything, and it has a unique value for the derivative, cos of log 2. Let us see if this exists somewhere. G dash of 0 is cos of log 2. Option D is the correct answer. Okay. Okay, so very simple. Differentiate this and identify that close to 0, the value of the function is also going to be close to will be positive basically. So I can keep this function as such and do the differentiation, substitution, everything in that. Question number 18. The differential equation obtained by eliminating the arbitrary constants a and b from xy is equal to a e power x plus b e power minus x is. This is a fairly straightforward problem. You should get a second order differential equation because there are two arbitrary constants. So differentiate this twice. First time if I differentiate x into dy by dx plus y into x becomes 1 is a e power x minus b e power minus x because of the minus x. Differentiate again, keep x constant, it becomes d square y by dx squared, and you keep dy by dx constant multiplied by 1 plus y into dy is dy by dx is a e power x plus b e power minus x. So this becomes x into d squared y by dx squared plus 2 dy by dx is, if you see that a e power x plus b e power minus x is xy. So this is the answer. Or if you rewrite it in another way, x into d square y by dx square plus 2 dy by dx minus xy is 0. And where do we have that? X d square y by dx square plus 2 dy by dx minus xy is 0. Yeah, the others don't match. So option A. 18, option A. Very simple. Just differentiate it twice. Question number 19. Relation R defined from 2, 3, 4, 5 to 3, 6, 7, 10 by x related to R. X is relatively prime to y. That is, x will be related to y if they don't have any common factors. Co-prime, in other words. So the question is, the domain of R is what? Okay. Now see what all can be related. Here 2 can be related to 3, 2 cannot be related to 6, but 2 can be related to 7. I am just writing the relation explicitly. Now 3 cannot be related to 3 because they are not co-prime. 3 cannot be related to 6, but 3 can be related to 7 and 3 can be related to 10. 4 can be related to all of them. 4 can be related to 3, 4 can be related to 7, but not to 6 and 10 because they have a common factor. Now 5 can be related to 3, 5 can be related to 6 and 5 can be related to 7. No common factors, but can't be related to 10. But already you see the domain has 2, 3, 4 and 5. So the whole set is the domain. Option D. Very simple. Let us move on to question number 20. Solution set of box of sine inverse of x is greater than box of cos inverse of x. Now let us just look at the function sine inverse of x for a moment. Okay, sine inverse of x. Now of course, what are the values sine inverse of x can take? It can take values, sine inverse of x can take values 1, 0, -1 or -2. How come? Because you know that sine inverse of x is from -π/2 to π/2, and this is like -1.57 to 1.57 roughly. So therefore all the integers that can come are 1, 0, -1 and -2. Same way cos inverse of x is from 0 to pi. Therefore box of cos inverse of x, if you know that pi is 3.14, can be 3, 2, 1 or 0. Okay. Now these two values are when x has to be negative. When x is negative, and then it will be greater than 3, greater than 2, even greater than 1 in some regions and all. So first thing is that they have given us sine inverse of x is greater than cos inverse of x. Now if x is negative, as I told you, this is negative, x is negative, cos inverse will be in the second quadrant, and this will be in the fourth quadrant, that is the negative value of x. So this will be smaller than this always. So x has to be positive. So you will look at values of x in the positive region. X, let us say this is 0 and 1. In this region between 0 and 1, let us consider what happens to these functions. So sine inverse of 0 is going to be 0, and sine inverse of 1 is going to be π/2. So sine inverse is, let's say, some function like this. Let this be sine inverse of x. So this has a value π/2. Cos inverse of x would be the other way, right? It will come down. This will be cos inverse of x. Here, this both will intersect at π/4 because sine inverse is equal to cos inverse of x. Now, how will the box function look like? The box takes integer values, right? So you find the value where beyond which this is 1. This is 1.57. So see, I'm going to find the value 1.0. And what will this point be? This point is such that cos inverse of x is equal to 1.0. This is sine inverse of x is equal to 1.0. So above this point, sine is going to have the, I'll use another color for the box values, box function. This is box of sine x. And here it will be a discontinuity, and it will be like this, 1 and 0. Now if you consider cos inverse, it will be 1 in all this region. Okay, here it is greater than 1, and here on it is less than, so it will be like this. Okay, so you see, box of cos inverse of x is this green line, and box of sine inverse of x is this blue line. So obviously this condition, box is greater than, not even greater than or equal to, it is greater than, is only this region from here till here. So what is this point? This point is where sine inverse of x is equal to 1. If you call this point as P, at P, sine inverse of x is equal to 1. So this gives x is equal to sine 1. So from sine 1, this value sine 1, similarly you can say this is cos 1. From sine 1 to 1, box of sine inverse is greater than box of cos inverse. Therefore the answer is from sine 1 to 1. Okay. Here for example, if you see, if this is greater than or equal to, you can say from cos 1 to 1, because from here to here, this is greater than or equal to this. The blue line is greater than or equal to the blue line. If cos inverse were greater than sine, then it will be from 0 to cos 1. The answer, if this is less than, the question if it is less than, then it would be 0 to cos 1. So you see how we have done, we have just drawn the graphs of cos inverse and sine inverse and then marked out how the box functions of those would look like using the value 1. So the answer is option C, sine 1, comma 1. Now we move on to the subjective numericals. Question number 21. F of x is given as cos of mod x minus 2ax plus b, okay, which increases for all x, then the maximum value of 2a plus 1 is. Now first of all, cos of x is an even function. So when x is, we know, mod x is like x when x is positive, minus x when x is negative, but cos of x and cos of minus x are the same. So the x can just be forgotten. Okay. So f dash of x, because we need to analyze the maximum and all, is minus sine x minus 2a. Now they have said that this is a function which increases for all x, which means it is strictly greater than 0. Let us say greater than or equal to 0. Okay. This would mean that minus sine x is greater than or equal to 2a. Or let us say, this would have been better, sorry, in the other way. That is, minus 2a should be greater than or equal to sine x. Now minus 2a should always be greater than or equal to sine x, and therefore sine x's maximum value is 1. So let us say minus 2a should always be greater than or equal to 1. Now this would give me 1 plus 2a should always be less than or equal to 0. So the maximum value of 1 plus 2a is 0. It should be less than or equal to 0, right? So the maximum value of 2a plus 1 is 0. Maximum of 2a plus 1 is 0. So the answer here is a big 0. Very simple question. You can just drop them out because cos is an even function. The distance between the point minus 1, minus 5, minus 10, so there is a point P, let us say, and the point of intersection of the line, there is a line with the plane, so there is also a plane involved. So they intersect at some point Q. This distance is equal to 13t. So the question is, what is the value of t? Very simple. Find the point of intersection and then find the distance and then put it is equal to 13t. How to find the point of intersection? Any point on the line should be of the form x is equal to 3. You write, you know, right? You put, okay, to make it a bit clearer, I'll write it explicitly. The idea is to take x minus 2 by 3 is equal to t, or since t is already used, let us say some k. Y plus 1 by 4 is some k, the same k, and z minus 2 by 12 is k. So x is 3k plus 2, y is 4k minus 1, and z is 12k plus 2. Clear? So since x, y and z are known, substitute them here. 3k plus 2 minus 4k minus 1 plus 12k plus 2 is equal to 5. This is, you are substituting the point in the plane to find the point of intersection. So this becomes 3k minus 4k minus 1k plus 12k is plus 11k. 2 plus 1 plus 2 is 5 is equal to 5, or 11k is 0, k is 0. Therefore the point is x is 3, y is, sorry, x is 2, x is 2, y is minus 1, z is 2. So this is q. So the distance PQ is going to be square root of minus 1 minus 2 the whole square, then plus minus 5 plus 1 the whole square, minus 10 minus 2 the whole square. So this becomes square root of 9 plus 16 plus 144, which is 169, which is 13. Now if this is given as 13t, t is equal to 1. So you see this very simple problem. The answer is 1. Just find the point of intersection of the plane and the line and then use distance formula to establish the distance. Question number 23. For n belong to natural numbers in the expansion of 4th root of x power minus 3, that is, I can write this as x power minus 3 by 4, plus a times 4th root of x power 5, that is x to the power 5 by 4. The sum of all the binomial coefficients lie between 200 and 400. That is, all the binomial coefficients, basically that is NC0 plus NC1 plus NC2 up to NCN, they say it lies between 200 and 400. Also the term independent of x, the constant term is 448. Then the value of A is how much? Now first let us find n from this. We know that this summation is nothing but 2 raised to n. And if we see which power of 2 lies between 200 and 400, it is only 256. Because powers of n, 2 power 7 is 128, 2 power 8 is 256, 2 power 9 is 512. So 2 power 8, 256 is the only thing which gives n is 8. So that is the first thing here. So you have n is equal to 8. Now write the general term. Tr plus 1 is going to be 8Cr x to the power minus 3 by 4 the whole power n minus r. So 8 minus r, and then Ax power 5 by 4 into r. So this is 8Cr times, let us say, here I get, let this should be properly written in this way. A to the power r and then x to the power minus, if I were to retain the whole thing with the denominator 4, minus 24 minus plus 3r plus 5r upon 4. So the independent term means the power of x is 0, term independent of x. So if you equate the power of x to 0, minus 24 plus 8r to 0, you get r is equal to 3. Substitute that back here. Fourth term is 8C3a cube. 8C3 is 8, 7, 6, 3, 2, 1 a cube, or 56 a cube. Now they have given that this term independent of x is 448. So 56 a cube is 448. A cube is 448 by 56, which is 8. So A should be 2. Right? So the answer to this question is number 2. Very simple binomial theorem based problem. First, establish that the n is 8 because that is the only power of 2 that lies between 200 and 400. Question number 24. A biased coin that has the probability of getting heads as P is tossed until a head appears for the first time. If the probability that the number of tosses required is even is 2 by 5, then 9P is equal to. So first of all we have to find how much is P. They say that they are tossing until a head appears, but even number of tosses are required. That is, it should occur in even number of tosses. That is 2 tosses or 4 tosses or 6 tosses and so on. So if head is P, tail is going to be Q, or which is 1 minus P basically. Right? Now for 2 tosses, if you get head in the second toss, you are tossing until head appears. So toss once, if you get head you stop, but that is an odd number. So toss twice. So first time you toss you get a tail and then you get a head. 4 tosses means you have got 3 tails and a head. 6 tosses means the first 5 tosses were all tails and then the 6th toss you got a head, and so on, no? 8 tosses, etc. So this would be Q into P, tail head. This would be Q cube into P. and this will be q raised to 5 into p. So the total probability in even tosses, okay, getting head in even tosses is qp plus qqp plus q power 5p and so on. So this becomes p into q plus qq plus q power 5 and so on. This is a GP. First term is q, common ratio is q squared. Therefore this becomes p into q by 1 minus q squared, because sum to infinity is a by 1 minus r. Okay, so if you know that this is given to be equal to 2 by 5, how to solve? Substitute q is equal to 1 minus p by 1 minus q squared, 1 minus p the whole square. So the numerator becomes p minus p squared, and the denominator becomes 1 minus 1 plus p squared minus 2p. This is 2 by 5, right? P minus p squared by 1 minus, okay. So this p minus p squared, let us rewrite this, and 1 minus 1 is gone, so I get 2p minus p squared. So p minus p squared by 2p minus p squared is equal to 2 by 5. Or you take a p and cancel it, and I get 2 minus p is 2 by 5. Or multiply 5 minus 5p is 4 minus 2p. Or minus 3p is minus 1, p is 1 by 3. So it's a biased coin, q should be 2 by 3. The chances of getting head is 1/3 and chance of getting tail is 2/3. Therefore, they have asked us the value of 9p should be 9 into 1 by 3, which is 3. So you see the answer to this problem is 3. Now let me show you something interesting. The last 4 questions, 21 the answer is 0, 22 answer is 1, 23 answer is 2, 24 answer is 3. So the last 4 questions the answers are 0, 1, 2 and 3. Can the next one be 4? Let us find out. If the straight line drawn through the point P is root 3 comma 2, so there is a point root 3 comma 2, and there is a straight line drawn through this point, makes an angle pi by 6 with the x-axis, meets the line, so this is one line that passes through this point, meets the line, so this is P, meets the line, another line, root 3x minus 4y plus 8 is 0 at Q, then the length of PQ is, basically find the equation of this line through P and angle pi by 6, solve it, get P, get Q and then find the distance. Very simple. So all I have to do is, first of all find this, find the equation of the line. See, what is the equation of the line? It's passing through root 3 comma 2. So y minus 2 is equal to m. M is equal to tan pi by 6, which is 1 by root 3. So 1 by root 3 x minus root 3. If I take the root 3 to that side, I get root 3y minus 2 root 3 is x minus root 3, or x minus root 3y is equal to minus root 3. Yeah, x minus root 3y is minus root 3. Now solve this, and let's say this is the first equation. Second equation is this equation itself. Root 3x minus 4y is equal to minus 8. To solve, multiply the first by root 3 and you write it here. Root 3x minus 3y is minus 3. Subtract them both. So go on, and I get minus y is minus 5, or y is 5. Substituting it in here, for example, x minus 5 root 3 is minus root 3. So x is 4 root 3. I got x and I got y, and all I have to do is find the distance between, so this point is 4 root 3 comma 5. So the distance between these two, that is 4 root 3 comma 5 and root 3 comma 2, the distance is square root of 4 root 3 minus root 3 the whole square plus 5 minus 2 the whole square. So this becomes 3 root 3 the whole square, which is 3 root 3 whole square is 27 and 9. So this is root of 36, which is nothing but 6. So the answer is 6. What is the other quick way of doing this? See, if you recognize that there is a line like this, there is this point, okay, P was here, Q is here, now this angle is 30 degrees. Now, if I drop a perpendicular to this, okay, drop a perpendicular to this and I find this distance, then how can you calculate this distance? This would only be this perpendicular distance by cos of this angle. So manage to find that angle somehow, and then you can you'll be able to get, since this whole thing is 90 degrees and all that. A bit tricky because of course this angle has to be known. Only after you find this angle you'll get this angle or this angle. So this angle will be tan inverse of all this. Find that and then you can go ahead with that also. See, this is root 3x minus 4y minus plus 8 is 0. If you know this angle, and then using that you can find what is this angle, and then this into cos of this is the perpendicular distance. Anyways, but here the most straightforward method I would prefer is find the equation of the straight line, solve them to find the point of intersection, find the distance using distance formula. So the answer we found was 6, therefore it is not 4. The last 5 questions were 0, 1, 2, 3 and 6. Okay, this brings us to the conclusion of NTA test paper number 7. I'll meet you with the solutions of NTA test paper number 8. Until then, this is SANTOSHSIR from Parth Tank Mathematics Institute, Ahmedabad.